record first. Good afternoon to you, Brian, once again. I hope you can hear me now. So, welcome to our subject, and that's Side 22 Agricultural Biology. And last time we talked about, um, we are already last time on the life processes. We talk about the water properties. So, please watch for the video on that. And we are now on about chemistry. So, hello, Brian. Can you hear me? So, what is chemistry? Although this is already just a review of your subjects before. I know you have taken up chemistry already, but in relation to agriculture and the different knowledge that you must able to remember when we discuss about agricultural production. So first and foremost, since you still cannot hear me until now, so if you would define chemistry, well, it's just the study, simply the study of chemicals, no, and solutions and chemical compositions, matter, and elements of a particular substance or natural resources. So the composition of matter is everything in universe is where which is composed of, and we call it matter, and it's actually defined as anything that occupies space or has mass, and therefore we are all matter, including the humans and all living things. So since we occupy space and mass, so we actually have mass and weight. And last time we have also defined what mass versus weight, and we all know that mass is the quantity of matter of an object, while weight is the pull of gravity of an object. So actually, when we say our weight, we usually refer it to it's not really actually the weight that we think of. So the we are actually thinking of a mass because it's our own quantity, but in relation to weight, so it's actually the pull of gravity, but we still use weight when I say in kilogram, no, because mass is has different definition, and it's actually we are referring to our actual weight. But when you use on your previous quiz, I've asked this question to you, and I hope um you have actually answered it correctly, and that we although we use our weighing machine or equipment, although we use weight, but then it's actually subdivided that it has a formula wherein you can already get the mass of our body, you know, of our own mass, or we call it in kilogram. So elements, when we say chemistry with the study of elements, so what are elements therefore? So these are pure substances that cannot be broken down chemically into simpler kinds of matter. So that's why they are actually elements, because they are pure substances. And in we have the so-called periodic tables, and so far on earth there are about actually 118 elements already, and that 92 of them are naturally occurring. So what are these elements? 90% of the mass of an organism is composed of four elements. We have actually oxygen, carbon, hydrogen, and nitrogen. So you can see in the periodic table the following chemical symbol. Like for helium, it's He, and its atomic number above it, and the atomic mass below or down. So just the same with fluorine, with a chemical symbol of F, and it is the ninth element, and it has a atomic mass of 19, and so on. So each element unique with chemical symbol and consists of only 1 to 2 letters, and the first letter is always capitalized. So what is atom? The simplest particle of an element that retains all the properties of that element. So this is illustrated in this figure. This is naturally an atom with a nucleus and electron and energy levels. So what are the properties of atom? It determines the structure and properties of the matter they compose. So our understanding of the structure of atoms is based on scientific models and not observation. So what is this scientific model? So we call this one the nucleus, and this is the central core of every atom. And we all know earlier that atom is the simplest particle of an element, and we all know that element is the pure substance, which cannot be broken down anymore into simpler one. So going back to the nucleus, hello Brian, can you turn off your mic because I can hear your background? You are there. So the nucleus again consists of a positive charge, protons, and neutral neutrons. Thank you, Brian. So now I know that you can hear me. So even though you cannot participate with me, or if you have questions now, just tell me. You can just turn on again your mic if you want to interrupt and ask question as we go along. Okay. So this is the nucleus. It has a positive charge protons and a neutral neutrons. So positively charged, of course, with a positive symbol and contain most of the mass of the atom. So the protons are all atoms of a given element that have the same number of protons. So number of protons called the atomic number, and the number of protons balanced by an equal number of negatively charged electrons. So these are the protons and neutrons and electrons which are balanced in the case of oxygen. That's why it has it is 8 8. So for neutrons, the number also varies slightly among atoms of the same element, and different number of neutrons produces isotopes of the same element. Like the isotopes of carbon can be it has 6 electrons and 6 protons and neutrons. They all have this is the isotope carbon 12, and the carbon 13 has 6 both electrons and protons but 7 neutrons. So once again, protons are positively charged while electrons are negatively charged and neutrons are neutral. And while the radioactive carbon 14 has 8 neutrons. So going back, and next is the atomic mass. So protons and neutrons are found in the nucleus of an atom, as discussed earlier. And protons and neutrons each have a mass of 1 atomic mass unit. So each of them has 1 AMU, or atomic mass unit. And the atomic mass of an atom is found by adding the number of protons and neutrons in an atom. So it's clearly said. So the electrons, or the negatively charged high energy particles with little or no mass, and travel at very high speeds at various distance or energy levels from the nucleus. So again, I have mentioned that electrons are negatively charged and they have little or no mass at all. Well, and electrons in the same energy level are approximately the same distance from the nucleus, and the outer energy levels have more energy than the inner levels, and each level holds only a certain number of electrons. So what are these energy levels? Atoms have 7 energy levels. The levels are K, closest to the nucleus, L, M, and O, P, Q, which are furthest from the nucleus, meaning they are far, and the only closer one is K. The K level can only hold 2 electrons, while the level L to Q can hold 8 electrons, called as the octet rule. So what is the periodic table? These are the elements arranged by their atomic number, and this is called the periodic table. The horizontal rows are called the periods and tell the number of energy levels, and the vertical groups are called families and tell the outermost number of electrons. So it is shown here. This is the vertical level, and it shows you the families. No, so by family they are classified as, these are alkali metals, and the green one is non-metals there, and the light one are the alkali earth metals, the transition metals, the other metals, the inert metals, the halogens, and so on. While the vertical um while the horizontal, rows are called periods and tell the number of energy levels, like 1A, 2A, and so on. No? So there could be more recent, because from by now there are already 118 elements in the periodic table. So you can also check for the latest one, the latest periodic table of elements. So that's all for elements, and most of them have different uses or various uses. And we know that potassium is very important for plants, sulfur, manganese, iron, copper, zinc, and so on. No? Carbon, hydrogen, oxygen, and so on. So, speaking about elements and atoms, so next is compounds. Most elements do not exist by themselves, no? These are readily combined with other elements in a predictable fashion. So they actually conjugate like this. Like this, these are the C9H8O4 or aspirin. So that's an example of a compound. A compound is a pure substance made up of atoms of 2 or more elements, and the proportion of atoms are always fixed, as shown on this figure. And the chemical formula shows the kind and proportion of atoms of each element that occurs in a particular compound. So these are examples of molecules. It's the simplest part of a substance that retains all the properties of the substance and exists in a free state, like carbon dioxide, ozone or O3, water is the molecule of water, nitrous oxide, CFC or chlorofluorocarbon, and methane. And some molecules are large and complex. So what are chemical formulas? These are the subscript after a symbol to tell the number of atoms of each element. Water has 2 atoms of hydrogen and 1 atom of oxygen. And coefficients before a formula tell the number of molecules. So 3 oxygen represents that there are 3 molecules of oxygen, or 3 times 2 is equal to 6 atoms of oxygen. So that composed of chemical formula. So what are the physical properties of a compound? usually differ from the physical and chemical properties of the individual elements when they are composed or combined. Like for hydrogen and oxygen have different properties when they are combined to as a water molecule, oxygen molecule and the sucrose molecule, which are more complex. No, we have 12 carbons, 22 hydrogens, and 11 oxygen. So the tendency of elements to combine and form compounds depend on the number and arrangement of electrons in their outermost energy level. So this is shown in this figure, the electrons and the neutrons and the protons here. Atoms are most stable when their outermost energy level is filled. So that makes them stable. Most atoms are not stable in their natural state and will tend to react or combine with other atoms in order to become more stable, which undergo chemical reaction. So like this, no, the hydrogen and oxygen are react can be conjugated to another or combine will readily react with other atoms. And in chemical reactions, the bonds are broken. Atoms rearrange and new chemical bonds are formed that store energy. So that's how um, atoms and molecules react together. And we have the so-called different types of bonds, since sometimes the chemical bonds are formed or rearranged. So we call them covalent bonds if they are formed when two atoms share one or more pairs of electrons. So like example of this are water. So these are covalent bonds because there are two atoms which share one pair of elect or more pair of electrons. So another one is the ionic bonds. Some atoms become stable by losing or gaining electrons. Atoms that lose electrons are called positive. So if you so it's if they at lose electrons, so electrons are negative, so they become positive ions like sodium and chloride. While if the atom gain electrons, they are called negative ions, so they become more negative. That's why they call negative ions. So that's what is ionic bonds about, because positive and negative electrical charges attract each other and other ionic bonds form. And it's the same with um, positive or negative, positive and negative attracts to each other. So example are the sodium atom, the chlorine atom, and this one. It's actually undergoes an transfer of electrons until you can see the different number of protons in and here, and the electrons were in at the last part the chlorine ion become um, having more electrons than protons. So energy and matter. The energy, we all know, is the ability to do work or cause change, and occurs in various forms which can be converted to another form, which is important to biological systems, and these are known as chemical, thermal, electrical, and mechanical energies, or free energy, or the energy in a system that is available for work. So what are the states of matter? Now we have discussed what composes the matter. No, we have the mass and weight, um, the atom, the smallest particle of an electron, and molecules as well. Now, what are the states? So atoms are in constant motion. The rate at which atoms or molecules in a substance move will determine its state. So whether it's a solid, liquid, or gas. I know you are very familiar with this one. Solids are molecules which are tightly linked together in a definite shape. That's why they vibrate in place and has fixed volume and shape. while liquids are molecules not as tightly linked as a solid and maintain fixed volume, but unable to flow and conform to the shape of a container. While gas are molecules that have little or no attraction to each other and fill the volume of the occupied container and move most rapidly and cause a substance to change state using thermal energy or heat must be added to or removed from a substance. So what are this energy and chemical reaction? Living things undergoes thousands of chemical reactions as part of the life process. So many are very complex, involving multi-step sequences called biochemical pathways. This is example of the glucose, the citric acid cycle. I don't know if you have remembered this one before on your past lessons, but this is actually the citric acid cycle wherein you can produce, we utilize, this is a chemical process, a biochemical process that will utilize glucose into for energy production, and this is part of the respiration the respiration pattern, no? So chemical equation represents chemical reaction in this figure illustration, and reactants are shown on the left side of the equation. So in an equation, and products are shown on the right side. So usually there are in chemical formula, on the left side are like when you remember the formula of photosynthesis. For example, you have carbon dioxide and plus water with the presence of sunlight and chlorophyll, so it became sucrose or carbohydrates, which are the products. So the number of each kind of atom must be the same of either side of the arrow. Equation must be balanced. So in this equation, you are just, adding or numbers to each kind of atom in order to balance both of the equation. For example, here, there are 3 hydrogens, so you need to balance them. These are balanced because the total of this is with the number of atoms are actually the same to the other. That's why sometimes there are number here, like in the photosynthesis. And bonds may be broken or made, forming new compounds. So actually this is all for the lecture. It's just very short, but and this is just a review of your knowledge on chemistry, especially about the composition of matter, and living things. So do you have any question, Brian, regarding the topic for this afternoon? Hello, Brian? I cannot hear you. Maybe you don't have a microphone, but okay. So that's good. I hope you understand the topic that we're talking about. So I just want to, okay, you just chat me with your questions or reaction. So I just, before we end, if you don't have any more questions, I will just remind you, because we are already now on Unit 2, and I would just like to remind you on the quizzes, which are due today, the water properties from the last time's discussion, and the chemistry actually is for that's for next week. The chemistry quiz, the our lesson for this afternoon, and most importantly, which is due on Monday, is the prelim exam. So I already sent this one, and this is about 100 items or more, and you just answer this one and make sure to give it back to me on Monday. So do you have any objection regarding this, regarding your prelim exam, Brian? Mm, ongoing na, pwede karon na concern chemical. Yes, but you make sure that you can answer back your prelim, no, before Monday or on Monday. Okay, do you have any problem with your if you have anything to ask or clarification for your prelim exam once you open this one, so you just can chat me on our Facebook chat group. Okay? Don't worry, because I just answer the exam whether you have permit or not. So, answer lang sa siya. And we will just, anyway, if you cannot pay anyway, um, the grades that I'm going to give you will not reflect anyway, no? So you still need to comply with your financial, obligation before you'll be given grades. So for now, you just take the prelim exam first. Okay, salamat din, Brian, for attending the class today, and I hope to see you again on Monday. No, not on next week. Next week, okay? So, thank you. Kung wala ka ng tanong, then we will end now. If not, then you just chat me, okay? So, that's all for this. Thank you too. And that's all for this meeting. And I will see you again on next week or next meeting. So, bye-bye.